discussion first. Okay. So containers are isolated and but shared with the OS, and where appropriate libraries and their application libraries are installed. So basically, a physical server are now having a hypervisor is running, or maybe your direct operating system is running. And on the top of this OS, you can create a multiple containers. But why? How you can create the containers? You cannot create the container directly onto this machine. You need some sort of tools. You heard about Docker? All right, great. So Docker is the tool that is used to create a container on your host operating system, right? Docker is the one who brings this concept. Since container is not a new concept, it is there since ages. It is from 1980 or 85. But but at that time, nobody was interested, right? Yeah, I mean not Dockers, all the containers. Before Docker, I mean before container is the inbuilt functionality of Linux kernel. Yeah. Have you heard about LXCs? LXCs kernel, LXCs, all these operating system terms, right? Yes, yes, it was there, but you cannot directly run. Yeah, yeah, yes, exactly. So it was there, but it was too complicated to run the container directly onto the Linux machine, right? So what happened? Docker, the name, the inventor of the Docker was Solomon Hykes. He was the person who was the inventor of Docker, and he wrote this Docker in Golang. Okay, and he is the person who brings this tool, and he said, use my tool and run containers on your operating systems. And yeah, so uh, what is this tool is doing, right? This tool is basically saying you can install it on top of your operating system, and then you can install your container, lightweighted container, on top of it. You can just pack it and run it. Now now we need to understand why container. Let me just let me just try it. I'm trying to help you understand how containers evolved from where, right? So let's say you have a laptop, right? You use laptop every day, right? You do it, right? So when you use your laptop, how many use can do you? So you log in, right? As a user, you log in, right? You log into your operating system. Let's say it's Windows, right? Let's say it's Windows, or maybe Linux, or anyways. So you log in, right? You what happened? You create your account with your name and you log in, right? Let's say your daughter also, your son also wants to log in. He can also log in, right? He can also create his account. So what we are doing here, we are actually creating the namespace. We are creating the user namespace, right? Just write something like that here. We are creating the user namespace. Means there is one single computer and there are multiple people can share it. There are multiple people can log in into this Windows or OS. So that's called user namespace. Now what happen if you log in to Windows machine? Do you see disk? You see disk, right? You see disk here. Maybe I'll just color it something. This see the disk here. And when your son also log in, he also sees the same disk. Then what we call it disk namespace, right? And then when you also see network, when you people log into, you also log into, you see um, a network as well, the Ethernet card, right? You also see the network, and your son also see, and the other people also will also see, which means there is a network namespace as well. Basically, what I'm trying to say, these resources can be shared, but the problem with the OS cannot be shared. I mean, the kernel. What is the heart of this OS? Is the kernel, right? The heart of this Windows or any OS is the kernel, right? And kernel cannot be shared. Kernel cannot be shared. Nobody can watch kernel. So the idea here come from the Solomon Hikes who managed the Docker. He said, when you can create a user namespace, when you can create a disk namespace, when you can create a network namespace, why can't we create a kernel namespace? If we create the kernel namespace, then you can think we can use this single OS layer from the kernel, and we can deploy multiple containers, right? So, which means this container will have its all these three things, all these three things individually separated and isolated. So this container has this user namespace, disk namespace, network namespace, as well as kernel namespace, right? When you have all these things bundled together, what it becomes? It becomes container. And when container runs, it is isolated. See here, it is clearly written, right? Container are isolated. This, remember this word. But share OS, which means these three things will be isolated, but this part will be shared with this host image. So, so behind the scene, it is taking their OS layer from the main host system, but these user disk and network namespace are isolated, will remain isolated. So if let's say if I create a second container, his this container too will also have this user namespace, but in a dedicated, isolated. He also have user namespace. He also had disk namespace. He also has network namespace, but in a isolated. This it has nothing to do with this. No, is this container has its own namespace, but the kernel, when it comes to kernel, it this container will also share with the host OS, but again will be isolated, right? I hope you understand what I'm trying to say. Okay. So the concept of container comes from here. So Solomon Hikes thinks about why not we should use a kernel to share the kernel with multiple containers, and from there the evolution of Docker has been happened. Now the Docker comes into the picture. So this functionality, you can find this functionality on your Linux machine, any Linux machine, which is called LXC, which we call it LXC container. But you can do this. You can deploy a container on Linux machine, but it is very hard. It's very difficult. You're gonna end up with a lot of configurations. And this configuration, this challenging part, is solved by Docker. Now Docker say, don't worry, I will take care of this complex setting and configuration. You just use me and deploy your container. I am pretty easy. You can use me. I have some commands. You can run the commands and I can deploy the container. Under the hood, I will take care of this complex configuration, the LXCs and all this PID namespace and all this, right? Yeah. So okay, okay. Okay, I'm not. I don't want to go more deep into it. Otherwise, there are a lot of things. So, one thing you need to remember: if you really want to learn Kubernetes, then you must be having the basic understanding of Docker. Okay, right? So you should learn Docker as well. Just the basic one, right? Why Docker is used. So when you install a Docker, I mean, I have this Docker desktop. I'll show you. Actually, I have just made it like this, right? So it is similar to virtual machine, but lightweight, wrong, but easy to understand. Is isolated way of running complete independent app environment, right? So physical, what is in physical machine? The kernel, the namespace, all this, everything has been mentioned here, right? Okay. Now, why do we use a Docker and why do we use container? Because so if you want to run your app at a mass level, how do you save cost and how to avoid the wastage, right? See, when you run your VM, when you run your virtual machine, you run your application. Do you think all the resources are always utilized? No, right? Mostly you will see 50% or 60% resource are utilized and rest 40-50% will never use in a lifetime. So if you are running 100 virtual machines, imagine how many resources are going wasted, right? So to avoid those wastage, you should use a container because container are lightweighted and they use only the memory and the resource that they need, and rest it will never use it. They will free it up for the other containers. So container are also used to reduce your resource, so it reduce the wastage to up to 20%, right? So architecture of Docker. So basically, a human, we actually interact with the Docker client, and Docker client sends the REST API to Docker daemon, and then the Docker daemon is interact with the container D, and then it interact with the OS kernel. Okay, I'll show you. So this is the Docker desktop which is running on my machine on my laptop. You can see that, right? So this is a Docker desktop, and now this is a GUI form basically. And here you can see that I have no containers. I think no, all the containers are in the stopped state. But if you want to run, you should have the image, right? You know about that, right? Docker's images container, right? Or should I explain you? No, I mean, if you know already, then you should tell me. Oh, okay, okay. Okay, no worries, no worries. So, so basically, this is a Docker, and I can use the Docker to deploy the container. Let's deploy one container, right? So, let's say I no. Docker has nothing to do with GCP. Docker is what I said. Docker is used to run your containers, right? So Docker handles how to run the containers, right? But Kubernetes, which Google offers as a GKE, as a managed offering, is an orchestrational tool, and and Kubernetes use Docker in their node in their compute engine, right? So if you are running your application on containers at a mass level, let's say you are running thousands, 2,000, 10,000 containers in your environment, Docker is not able to manage those containers. Only Kubernetes can manage it because Kubernetes is an orchestration tool, right? Now, Docker has its own own work. Kubernetes has its own work. I'll come to it. I'll come to it. Okay. So first need to understand what is Docker, right? You, that's what I said. If you don't know Docker, you can't learn Kubernetes. Yeah, yeah. So we need to you see containers runs when the Docker is there, or or any sort of for Docker related software. I mean, there are many product which are competing to Docker, like we have that Rocket one, the Docker, and then there are others applications are also there, which provide the similar functionality what Docker, right? So so basically, what happens when what happened? What Docker is made up of? The components of the Docker are Docker engine, Docker image, Docker registry, and Docker container. When you run an image, you get one container. When you run this same image 10 times, you get 10 containers. Now, what is image? What is Docker engine? What is image? What is registry? What is container? Right? You need to understand. Docker engine is nothing, is just an application. Okay, it's just the application, which is something like that. This is Docker desktop in a GUI base, but something like that that is running. You can think about Java runtime, something like that, right? So this is a Docker engine. So that is this is the Docker engine which works. Let me show you uh, Docker architecture diagram. This one is fine, I guess. Yes. So understand this thing. Okay, so this is your host machine, right? This is your VMs or any host machine where your some sort of OS is running. So in the VM, you have some Docker daemons are running or Docker engine. You can also say Docker engine. This is your Docker engine, and this is your Docker client, and this is your registry, right? So this is your VM. This part is your VM, the Docker host where your Docker daemon is running. When you when you interact with the Docker engine, you interact with the Docker client. Now Docker client has some commands: Docker build, Docker pull, Docker run. When you run execute those command will be hitting to the Docker daemon. And let's say you want to create some image, the Docker image. Remember that containers cannot be made without image. You need to have some image, right? Now what is image? Image is made up of your application and your OS sharing, right? So to deploy the container you need image, so you need to first build the image. Now where do you build the image? You build the image from your app, from your source code, right? Let's say you write the code in Java, right? Now you want to, when you want your application to be dockerized or containerized, so you need to write some Docker file, Docker command to make it as an image. And then once your image is ready, you can push it to the containers. When your containers are ready, right, then your users can access this. Now where are those images can be stored? Those images can be stored in local or can be stored in the registry. It can be a local registry, it can be your Docker hub. So Docker also provide the hub which where you can store your images. Understood? So this is, yeah, this is how the Docker architecture is there. So Docker engine, Docker image, Docker registry, and Docker container, right? So one thing which I wanted to explain. So Docker image is nothing. Let's say you have some source code, right? You have some source code you written in Java, right? Some Java, and then you have some index.html, right? All these CSS, ESR file, everything is ready. Now you want to, as a developer, you want to Dockerize it. You so what do you do? You basically, you know, create an image. Now, what is image? So image will made up of an OS, right? A lightweight OS. It could be at various types, kernel, Linux OS, Windows OS, but it is a very lightweighted because the OS is shared. It is taking the OS from the physical VM. Let's say this is your physical VM. This is your physical server, and top of that, some VMs are running, right? Now this is your container. Now then you will you will add your code here, OS. You have some applications, you have some dependencies, right? Then you have some libraries and all this made your container, and it would be very lightweight. Let's say it had 100 MB. So all your source code will be converted into images. Now what would you do with this images? This is your image, sorry, this is your image, like that. From the image you can create your container and you can run those containers, right? So what is an image? It is made up of your root file share or the OS, the user uh, file space and application file space, right? So basically OS, user and application. So what do you have in image? You have in a container. You don't have in image, you don't have in containers. Understood? If you don't have image, you don't have container. If you have image, you have container. Well, now what is file system? The file system is your boot FS, root file system, user file system, app file system. And the registry, as I told you, a place where you can store downloaded and uploaded view multiple images. So the registry is of two types: public registry, which is a hub.docker.com. If you just copy this site and open it here, you can find it. See, this is this is my account already login, so I can see that I have number of images are there which are publicly available. So Docker also provide official images. Google also provides official images on the Docker Hub. You can find it. So let's say if you want to find it here, Nginx. Have you heard Nginx? Yeah. So Nginx image. Let's say Nginx. So you can find those images publicly available. So see, this Nginx has also published their Docker official image, and you can see 1 billion plus download. Can you see that? Yeah. And you can create your image. This is the command docker pull nginx, right? And this is the command that can show you how to use this image. There are some of the command, right, which you need to learn. So to avoid typing those commands, this typical command, you can run Docker Desktop. So Docker Desktop is a GUI version similar to Google Console, right? Whether you want to use Google Console or Terraform or the Google Cloud SDK. So if you don't want to interact with Google Cloud Console, you can use the command line. So basically, I don't want to use a command line. I want to use a GUI. So this is a GUI version of Docker. Okay. So let's say I have the image, this image, this Nginx. Okay, can you see that? This image, right? I want to deploy. Yeah, so I want to deploy this. How can I deploy? Let me just delete it first because it is attached, right? How can I deploy? So this image, if you just click on this image is made up of this thing. These are the layers. Remember, images are made up of layers. Images are made up of operating system, application, libraries, command, all those things. So you can see that this image is, I think, how much? If you just 61.5 MB or how much? Almost not more than 100 MB. You can see that the size, right? 80 MB, something like that. And these are some of, okay, I'll come to this later. Okay, now this is my image, Nginx image, which I have downloaded it from the Nginx official website. Now I want to deploy this. Think this image as the whole operating system, right? Think this image as the whole operating system plus your application libraries, right? So you can also think this image as a lightweight version of the VM. Now I want to deploy my container. Now look, in just a fraction of seconds, you can deploy the container. Do you think you can create your VM in 2 seconds? No, right? Never. You will, when you deploy a compute engine, you're going to end up at least 20-25 minutes overall, from creating a VM to deploying the application to open the firewall and all these things, right? Now, I want to create a container. So what are you going to do? I told you, containers cannot be made without image. So just click on that. Do you see here, run this command? Yeah, just click on run. There are some optional setting. If you want to name it, let's say I want to name it my nginx container. These are optional. I will tell you later. Just run it and blah, done. Your containers is ready. Can you see that? Your container is running. See, status is running. How much time it took? Just a 1 second. The size. Oh, this is the container memory size. Sorry, don't worry. The size is only the image size. Okay, now I want to access this. How do you access it? Let's hit into it. And here you can see this. Where is that? Okay, so right now you are into terminal. I'm logging to my container. If you want to see my, so I am right now, I am logging to my container, and you will see all this file. See, bin, boot, dev, docker. These files are a part of your operating system. You have seen those file in your Linux, right? Boot, dev, all this file. So this small container is containing not just your OS image, but is also containing the nginx. So if you run system ctl status nginx, maybe system, okay, sudo, or what is that? System system ctl status. Oh my god, typing is not working. Oh, anyways, now I want to see in external or not that. I want to access this. How can I access this? Where is that? It's details, terminals, stats. How can I access that? Hmm, I think I have not exposed it. Oh, no, anyways, let's just delete it and deploy it again. So from the image, go to image again. So you can create n number of image, right? I'm going to create one more. Okay, so here you need to export it, right? So just name it nginx container one again. I'm saying, let's say host port. So host port is, I'm saying 4000, right? So when I hit my on my local port 4000, it is going to forward it to 80. Okay, and that's it. Now I should be able to access it. Open in term. Okay, open with browser. Ah, I can see that. See, see, it's running, right? This is how you can forward it. Okay, so you understood, right? What are the images? What are container? If I want to create one more container, can I do that? Yes, absolutely. Yes, run it again. Name it something else. Maybe I will tell it Shinto one. I can run it. Let's say this time 5000. The port has to be different. Remember that. Okay, right. Now go to container. How many containers are running? Yes, absolutely. And with a single image. Now, if you want to see, you can. Okay, it's running. And if you want to create another, you can have it. Oh, let's say I want to create 2000. Say Sumit. See? Okay. See, with one image, you can say if you want to access it, just access it. See, on 2000, it's running. So things are getting easier here, but containers management are too tricky. Trust me, too tricky with Docker, right? You cannot manage your multiple containers with Docker desktop, and that's where Kubernetes comes into this picture, right? You cannot scale it. You cannot scale the Docker. If say if you want to deploy a container onto the multiple clusters, then what happened? Dockers cannot scale it, and that's where Kubernetes comes into the picture. Now I'm gonna just delete those one because I don't need this. They just eating my memories. Okay. Okay. Now let's talk about Kubernetes. For this, let me grab Kubernetes architecture. Yeah, I think this is fine. So Kubernetes say if you want to deploy any application on containers, okay, you can use Kubernetes. Now Kubernetes is saying you have multiple nodes, right? Under the hood, there are some nodes, right? Which is nothing but a compute engine. So compute all this compute engine is basically handled by a master server, right? So Kubernetes in short, you can say a one single data center, right? This is the meaning of the actual meaning of you can say Kubernetes. Okay, one second. Let me open my detail. So Kubernetes is made up of four components: the master, the control plane, and the node. On the right hand side, you have node. On the left hand side, you have a master node. Now, master node is again made up of three components: the controller, the API server, the scheduler, and the key value. And here is the user who interact with the Kubernetes using the CLI APIs and the dashboard, right? So master servers is actually control the nodes. All these nodes are running your kubelets. I'll tell you why. And all these nodes are also running the Dockers, right? So these are also running the Dockers. It's also running the Dockers, right? Because I told you, right? If you don't have Docker, you can't run the containers on top of your nodes. So this is needed to 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 run containers. This is needed. If you don't have Docker or equivalent software, this Kubernetes fails. This will not work out. And by the way, for just for your information, the history of Kubernetes, I'm telling you. One second. Kubernetes history. See, so Kubernetes is a container orchestration platform that was developed by the engineers at Google. Can you believe that? Yeah, based on their experience with Borg. So earlier the Kubernetes name was Borg. It was invented by Google only. And Google is using this technology since decade in their own data center. So what happened? Kubernetes basically called Borg. So what happened? Google think like this is something that should be a open source. So Google has donated this technology to CNCF, right? Now CNCF is a cloud native computing foundation. This is a foundation who manage this Kubernetes, right? Let me just show you in the Wikipedia. So Kubernetes is an open source container orchestration system for automating the software deployment, scaling, and management. The name of the Kubernetes originates from the you can see some the name, and here you can see this project is now maintained by the CNCF, right? So the design and then development of the Kubernetes were influenced by Google Borg. You can see that cluster manager and based on the promise theory. So basically what happened that Google think, okay, why not we should donate this technology to the CNCF, and CNCF will has open source it. That is why nowadays every cloud provider has a managed Kubernetes service, right? Because the things are open source, they have got the code and they have deployed it in their own environment as a managed service. Let me grab my water. So um, so this is the architecture of Kubernetes. In every whether it is a GKE or whether it is a AWS EKS or Azure AKS, whatever Kubernetes in any form, this is the ultimate architecture. Okay, so what happened? Yeah, the API, this master server is made up of different this four component. This so API server is very important. The API means it is going to interact with your user. The user interact with the API server. Yeah, right? Let's say if you want to create a container on the nodes, then you should interact with the API server. Now API server is the one who interact with the scheduler, controller, and the key value store. This is something we can call it database. This is also called HCD database as well. Okay, remember that, right? And then it install your container in the form of pod. So basically, you heard about pod? Hmm. Okay, okay. So basically, pod is nothing. It is a container. Okay, pod is nothing. It is a container. But when you deploy this container through Kubernetes, now Kubernetes say if you're deploying container through me, then I will create on one more layer onto that, which is called pod. Because I don't know what is container. I know my pod. I will deal my pod. So pod is again a top of a boundary on the containers, because container is managed by the Docker, right? And pod is managed by your Kubernetes. So if you manage the pod, ultimately you are managing the containers. So pod is the smallest unit in the Kubernetes. Simple, simple language, right? So as an user, if I want to deploy pod or container in a Kubernetes cluster, I would always say pod, not container, because ultimately it is a container. A pod can have one container and it can have multiple containers as well, right? So now here the things are getting changed, right? The pods can have one more container here, okay? And when you have, let's say here I'm telling you this is a pod, right? This is a pod, and you can have container one, you can have container two as well. So let's say this container one, right? This container is running some Java application. This container two is sort of supporting application maybe, right? Which is supporting C1. So so this container one and container two can talk to each other, right? and this entire thing is managed by the pod, right? So the pod is saying what I told you, that every container or every pod has its own user namespace, disk namespace, network namespace, right? So now those things are managed at the pod level, not at the container level, right? Yeah. So things are same. Only thing that is changed here is the pod. Now Kubernetes is saying, I don't know containers. Who are containers? And literally, Kubernetes never know what inside it's. Kubernetes knows only the pods. Okay. So, anyways, what I'm saying, API server is basically, dealing with, to deploy the containers, right? One second. Okay. So you have this API server, and which is used to deploy your containers. And when it deploy with the containers will need some images, right? And the images will be pulled from the Docker Hub or whatever registry you want to have it in on environment. Now, what is scheduler? So whenever basically request API server to create the Docker or to create the pod, right? What scheduler is does, scheduler will schedule your pod onto which node I have to install the create the pod, right? So you don't know where the pods is going to install, which node. Let's say you have 3 node cluster, right? So you don't know. So scheduler will check, okay, which node has the enough resource available. And based on that, scheduler will say, okay, the node 3 has less pod. Let's deploy it here because it has less resource. So Kubernetes use this scheduler as an algorithm to understand where to locate the pods. Okay, that's the name is very clear. Scheduler. It schedule it your pod, and then it get back the information to API server, and API server talks to your node, right, using the kubelet. Now, what is the role of controller? I will tell you controller, why controller is used. So controller is used to deploy your replicas. Y- So let's say if you understand those terms, uh, let's say I want as a user to create a deployment with 3 replica, which means 3 pod, right? Now you say this is my desired request. Now what happened? Your 3 pods are running here, here, and here, right? Now what? Let's say for any reason this pod goes down. For any reason, let's say some bug, some application code. For any reason, this pod goes down. And remember that when the pod goes down in Kubernetes, it will never come back. It will go away. It will delete forever. What happened? Because the pods are ephemeral. Pods are ephemeral. Understand ephemeral, right? Which means they are not static. They are not live forever. When they have an issue, they deleted and they are replaced by the new pod, right? So basically, pods are like a cattle, not the dogs. Understood, right? Yeah, that's why we treat pods as a cattle, because cattle gives us some milk, right? They give some milk, they give some, what we call cream and all these, and that's why we treat cattle more than no the dogs or the pets, right? So when your cow don't give you the milk, what you do? What are you gonna do? If you have a let's say you have a dairy office or dairy farm, right? You have 100 cows, right? And this those 100 cows, one cow give you 10 liter. Then 100 cow will give you 1000 liter, right? Every day. Now, what happen if one of your cow goes down? Maybe she's not well, or maybe she died for any reason. And what happened? Your production will reduce 10 liter, right? Now your farm will produce only 990 liter. So what are you gonna do? Do you think do you replace that cow with the new cow? You will have to to fulfill those 10 liter, because you have to serve the demand, right? This 1000 liter, right, by 100 cow. If one cow die, then what happened? You will produce 990. So where do you bring that 10 liter? Obviously, you will buy one more cow to make it 100. 100 functional cow who produce milk daily. That's right, right? Kubernetes works in the same way. I want my three cow, my three pots, for any whatever reason I need. If this pot goes down, you make sure I will make sure controller do one thing. If my pot goes down, make sure you deploy the another one right away. Understood? So my desired capacity will always remains three. So my desired capacity equal to what we say. I forgot the name. So basically, controller is used to make your desired capacity available. I hope you understand what I'm saying, right? I want my three pods every time running. So your three pods will always be running, no matter what happens. No matter what happens to any cow or any pod. If any pod go die, then it will spin up a new pod. So it will always see the controller. Okay, my deployment has three replica, and now I have two. Well, the one goes die. Let me create one more, so that my desired capacity three will always remain same. Right? This is my deployment. The deployment is a Kubernetes object terms. Right? So let's say in future I want this three to five replica. You can increase it. Then three pod and two more. Let's say two more. One, two, three, four, and five. Have five pods. So you can instantly increase your replicas. Okay. So this is the functionality. This is one of the functionality that is managed by the controller. Remember that. Now coming to the HCD, which we call it key value store. Now what is that? What this is a database. Whatever you are doing, let's say you are creating the pods. The API server will store this information to somewhere, right? Where it store? It store into the database, right? Because every information, whatever this API server is doing, it has to store the information. So it use the database. And let's say you have created the deployment, you have increased the replica, and whatever containers are pulled, every single information is stored in this HCD database or key value store database. If this goes down, it will have a great impact. And that's why sometime HCD has a multiple copies, okay, for the backup purpose, right? Because of this GKE and there's all this cloud provider class Kubernetes or GKE, they manage their backup and all these things, because you just this is like a managed service, right? It's like a it's like a Chinese starter. You just go and they serve it instantly and just eat it. You don't need to, you know, cook your food, light your this gas and cylinder and all this. You don't you don't need to bring those things. The cloud is something like that, right? It is giving you the cooking food, cook foods. You just spend money and eat it and enjoy our life, right? So similarly, Kubernetes is also the same way. Understood? Any questions so far? Yeah, yeah. So, but if you really want to learn Kubernetes, I mean, Kubernetes has altogether a separate topic, a separate course, a separate training, right? And it is not a it is a very advanced, very complex technology so far. Kubernetes is a wonderful, is a magic, but and it brings a value to your business. But every costly, I mean, every valuable things comes with some certain sort of complexities. So you can't find engineers to manage them. I mean, if you're finding the people, Kubernetes skilled people on Kubernetes, there are very less people are there. And if you hire them to manage the Kubernetes in your company, I mean, they're gonna pay a lot, right? Yeah. So, any question? No question, right? You understand? You have to understand this thing. Master and nodes. Master is this four component. Yeah, the master. Yeah, yeah. So master is sometimes called control plane. So don't get surprised if someone say, "What is control plane?" Control plane is nothing. It is a master, right? Control plane is made up of controller, API server, scheduler, and this. Okay, and here on the node side, you have the Docker installed. You have this kubelet. Kubelet actually, uh, your API server always talk to kubelet. Okay, and kubelet talks to your Docker basically, right? I mean, kubelet is the one who manage your nodes. It's like a servant. It's like your waiter, which keeps going to each and every table and asking for things like what do you like to have, right? All those things, and send information back to the kitchen. This is your kitchen, right? This is how kubelet works. The API server works. Kubeproxy is something that is used for networking. I'll talk to you later what kubeproxy does. So those things are done. Okay, all right, let me drink water. Do you have any meeting? What time? In 10 minutes. Okay. All right. So 5 minutes. Let me show you some glimpse of Kubernetes here. If you log in, you'll see this Kubernetes engine. So just click on this and go to cluster. So in this Kubernetes engine, you can deploy Kubernetes cluster and all this, right? So basically, when you deploy a cluster is nothing. Cluster is made up of master and nodes. All these entire things, not this entire thing is called cluster. Yeah, and in GKE, this particular part, this master part, is managed by Google. You would not see it, right? You would not see it. You will log in. You will log in because to interact with the Kubernetes, but you can't see this controller, API server, scheduler, and all this thing because this is completely managed by Google. And if something happens to it, Google will be responsible. That is why people are choosing cloud-based, Kubernetes, because these particular things are very complicated. If you are running onto your on-prem, right? If you're running this on your on-prem, your things are very getting complicated, right? So this is how you install it. I will cover this maybe when Tai will join the call next time, or when we cover the compute engine. Okay. All right. So I think we are done today. So tomorrow, please join. I please ask Tai to join the same time. Okay, 10:30. Then make it later. Make it later. What time? 11. Okay. Then do one thing. Check with Tay. You guys please check with each other and come up with some time, some good time that fits me and you. All right. All right then. Thank you. Bye bye.